Hi, good afternoon everybody. My name is Jillian Preston, and this is the Week 15 Tic Tac Toe Python game here. So I have it pulled up right here for you, and we're just going to go ahead and first of all, before we jump in and play around with it a little bit, I'm going to show you my code here. I'm going to go right back up to the beginning, and I'm just going to go over it a little bit and explain it for you. So I have broken down my code into 5 main sections. We have the game board, game logic, player input, single game, and then the main game loop. So I'll briefly explain kind of each section and the troubles that I encountered with each one. So this right here is going to be our game board. So the game board section is responsible for creating, displaying, and updating the Tic Tac Toe game board. The import random function right up here, that statement is included at the top of the program so that we can later generate random moves for the computer player that I've inserted in this game here. So this new board function, as you can see right here, that creates a new board at the start of each game. It uses a list of 10 empty spaces and leaving index at 0 unused so that the board positions 1 through 9 directly match the number that the player enters here. So this makes the code a little bit easier to read and also helps prevent indexing errors. The print position guide function shows players which numbers correspond to each square on the board. So this helps for when you're playing the game and choosing kind of where either your X or your O is going to go. You can choose to put it at position 2, position 5, position 8, 4, 6, 7, 9, wherever you want to go. It just helps you kind of make that decision of where you want to put it on the board. So, this function also kind of displays the current state of the board using the values stored in this list, updating after each move so that players can see the game progress. So that's where you can kind of see all of this right here. So update board, that function places an X or an O on the board at the chosen position. One issue that I did encounter while creating the board involved matching the player's input to the correct board position, as I was kind of just explaining. This problem was solved by leaving the index 0 of the board list unused. So see how this is kind of multiplied by 10 here, but we only have 9 places where you can select on the board. That's intentional. This is just so that, everything the 1 through 9 player directly enters matches the list index used on the program, and everything kind of matches up on screen here. So this does not change how the board looks, but simplifies the logic of the code and prevents symbols from being placed in the wrong location. We're going to go over here to game logic. So the game logic section controls how the game actually works, including switching turns, checking for a winner, detecting a tie, and determining which moves are still available. The switch player function here handles changing turns between players. If the current player is X, the function returns O. If the current player is O, it returns X. So this kind of allows the game to alternate turns without repeating the same code over and over again throughout the program, so we define it as a function. The check winner board here, so this one right here, this checks all the possible winning combinations on the board. It compares rows, columns, and diagonals to see if there's 3 matching symbols that appear in one of those ways, either across the board, down, or diagonally. If the winning condition is not found, the function returns the symbol of the winning player. If no winner exists, it returns none, so it just kind of allows the game to keep going. So here we have the check tie function. This determines whether the game ends in a tie. It does this by looping through the board positions 1 through 9, so kind of how we learned in that sequential algorithm is just checks to see if there are those matching values either in a row, diagonally, up and down, whatever. And so it's just going to sort of check to see if anybody won. If nobody won, is it a tie? So if at least one empty space is found, the game is not a tie. So if there's an empty space, somebody can still take a turn, so then that's not going to be a tie. So if no empty spaces and no winner was found, then the function returns true, indicating that it is a tie. So then let's do available moves. Get available moves function creates a list of all open positions on the board. It loops through the positions 1 through 9 and adds any empty spaces to the list. This function is especially useful when the computer player needs to choose a valid move. So like I said, kind of mentioned before, I added a computer player to this game so that you can choose to play with someone or you can choose to play against the computer. But one challenge I encountered in this section was correctly identifying when the game should kind of declare a tie. The first kind of version of me going through and coding everything and seeing if everything worked, it detected a tie before I would put one value in, right? So I would take my first turn, I would put an X in value 5, and then it would return tie. Even though nobody else had taken their turn, I only entered in one value, the board was still completely empty, basically. So fixing this kind of took a while, because everything was the same here. Everything was the same. I just didn't have a space there. So it's very important to make sure that you're putting your spaces in the right place and indexing or indenting in the right places as well. Okay. Player input. So the player input section is responsible for safely collecting moves from the players and ensuring that all input is valid before updating the board. So right here, the get player move function kind of handles input from the player. Pretty straightforward. It uses a while true loop so the program keeps asking for input until a valid move is entered. The function allows the player to type a number between 1 and 9 to choose a square or type quit to exit the game. Several checks are performed to prevent invalid input, such as entering letters, numbers outside the valid range, or choosing a square that's already occupied. If an invalid input is detected, the program displays an error message and prompts the player again. So next one here is going to be this one, right? So the get computer move function is used when playing only against the computer. It gathers all available board positions using the get available moves function, and then randomly selects one of these positions. This ensures, however, the computer always chooses a valid move without needing complex, decision-making logic. After playing the game myself a few times, I did realize that it just entering in a random move every time makes the computer extremely easy to beat. I think that if I was going to make this an actual game, I would go back through and make the decision-making logic for the computer player a little bit more advanced, because it's ridiculously easy just having it choose a random position every single time. But it still works, right? So it works. So one challenge in this section was preventing the game from crashing, kind of due to invalid user input. So using the input validation and looping until a correct value is entered helped ensure that this program just actually kind of runs smoothly if the user enters in, instead of a number, or they put a letter, instead of a letter they put a number. It's just really important that we have that error check, and then it goes back through the program. So another issue that I did encounter as well was that the program did not recognize the word quit when it was typed in uppercase or with extra spaces before or after. So that was resolved when I put in right here. So you can see it right there. That, and to move extra spaces, I used, where'd it go here? This. So these two make sure that when you do type in quit, whether you type it in an all uppercase or you add an extra space, it kind of just converts it to lowercase and then removes the spaces so the input is still valid. And then we're going to go ahead and move on to the one game section. So the reason why I'm kind of calling this one game is because this section of the program controls everything that happens during the single actual game of tic-tac-toe, from the moment the board is created until the game ends with a win, a tie, or the player choosing to quit. Separating one complete game into its own function makes the program a little bit easier to manage and allows a main game loop to restart without repeating the same code over and over again. So this one game function begins by creating a new board and displaying both the position guide and the empty game board. It then checks which game mode was selected, either player versus player or player versus computer. So based on that mode, the function gathers player names, assigns symbols, and determines whether the computer will be making moves. The game then enters a while true loop, which represents the active gameplay. During each loop, the program determines whose turn it is and either prompts the player for input or allows the computer to choose a move. After a move is made, the board is updated and printed so that you as the player can see the result. After each turn, the function checks for a winner or a tie, for a win or a tie. If a player wins or the game ends in a tie, the function prints that result and returns a value indicating the game is finished. The function also allows the player to exit by typing quit, which just safely ends the current game. So a challenge in this section that I kind of encountered was managing multiple conditions inside the game loop, such as switching players, checking for winners, and stopping the game at the correct time. This was handled by breaking the program into single self-contained functions, each responsible for one specific task, such as switching players, checking for a winner, or detecting a tie. These functions were defined earlier in the game logic section and then reused inside the one game loop. If the program was not broken down into separate functions like that, all of this logic would need to be written inside the game loop and then kind of repeatedly rewritten. So that would have made the code a lot longer and harder to read and a little bit more difficult to debug. So using these functions in different sort of sections helps just make it easier for everybody. And then we're going to go down to the main game loop here. So the main game loop controls the overall flow of the program and allows the game to run multiple times without restarting. So the main function begins by welcoming the user and entering a while true loop, which keeps the program running until the user chooses to quit. Inside that loop, the program prompts the user to select a game mode, either player versus player or player versus computer. Input is validated to ensure that only valid choices are accepted. So if the user types quit, the loop ends and the program exits correctly. If you type your name or something completely random, then it'll just ask you again, which mode would you like to choose? Do you want to do player versus computer, or would you like to quit? Once a valid mode is chosen, the play one game mode function is called. So we go back to now you're actually playing that game, so that function is going to start now. This runs a single complete game and returns a value when the game ends. So the main loop uses the return value to determine whether the user should choose to quit or whether the game just ends normally after all turns are taken. After the game finishes, the program asks the user if they would like to play again. If the player answers yes, the loop repeats and a new game starts. If not, the program prints a closing message and just exits. This structure allows the game to restart easily while keeping the logic organized and easy to follow. Finally, calling main here at the bottom of the program starts the game. So one challenge in kind of making this section and making sure the loop ended at the correct time without causing the program to crash or repeat unexpectedly. Careful use of the break statements and return values ensured that everything kind of worked the way it should. Overall, though, I think the hardest part of writing this program was organizing it in a logical way and breaking down the game into its most basic steps. That's always the part that I have the hardest time with, because my instinct is to start building what the user sees first, such as the game menu or the game display. I want to start from the menu and then work it down. Do you want to play player versus player? I want to organize that game menu and then go from there. But programming doesn't work like that. It doesn't work like how the user experience this program. You have to kind of almost think backwards in a way. So instead I had to focus on separating the logic, user input, and display into clear sections before everything can function together, like kind of how you see in my code here. So this requires, thinking differently than I normally would and planning the structure of the program ahead of time. And, using pseudocode is really helpful. I think breaking down the problem into smaller pieces helped me understand the flow of the game a little bit better. So this is my final code here. And if we minimize my little pie chart here, you can see that I opened it in its file. So it says right here, choose a mode, player versus computer, or I can take quit. Let's play with the computer. So we're going to take 2 to play with the computer. And then our position guide here. So I'm going to enter my name. So Jillian, my little, O or X, I get an X. So I can choose square 1 through 9 to place my X. So I'm going to go 5 because I like to choose the middle. And then the computer chose a move, so they went in section 9 there. So I want to win, obviously. So I'm going to choose square 8. There we go. And this is kind of what I was referring to originally, that the computer is not very smart. I mean, that is by my own design, and it's not really the computer, we know this. But that's something that I would like to improve in the future, is just to make that logic a little stronger so that it, thinks about blocking the player and where the player might go, instead of choosing somewhere the player, the other player probably wouldn't go. So I am left here wide open. I can just choose 2, and then I'm going to win. So I win. Do we want to play again? No, we're not going to play again. So then it just exits right there. One more thing I want to do, though, is just open it up again and show you that, the player versus player. That one works too. So this is me. This is you. And I'm going to choose square 1, square 2. It functions the way it should. And let's do quit. I'm done. Done. See? Okay. So that was my Tic Tac Toe game. That was kind of the logic, the game itself, the code here. Thank you all for watching, and I hope you have a great rest of your day. All right.